Hey everyone, welcome back to the Saksham Vedi channel. In the past video, we discussed about a lot of things in system design. In this video, we are lecturing about, we are talking about process versus thread in a scalable distributed system. But why process versus thread? I think it's a basic topic and every beginner should know this but we are learning this topic still from our childhoods, but let's learn today in a more detailed version. Okay. So I will try to explain you an example. So suppose there's a restaurants, okay? There are restaurants R1, okay? Now, if you have a city, suppose this is a city, okay? This is a city. Now, in this city, we have a different restaurant. Suppose R1, R2, R3, R4, R5. So these are the restaurants, okay? In these restaurants, suppose we go on R1 and in R1 what we have kitchens, we have utensils, we have ingredients, okay? And in this inside we have a threads which is worker, suppose which is chef 1, chef 2, chef 3, and all these chefs share these utensils of this restaurant. So suppose one process is fired up, this is gonna fire, like a lot of fire is happening and this restaurant is closed. So if you want on a random Sunday, if you want to go on a dinner, should all the restaurants is blocked for you? Should you do not able to go in any kind of restaurant? No. You can go to R5 if it is that closed. You can go to R2 if that is closed. You can go to R1. So So here you see there is an isolation. Here is an isolation between these restaurants. Like they are not mutually dependent on each other. If one crashed, all the crash. It's not happened. So this is called process. In the programming word, I want to explain you. So process is basically a pre a space where some task is executing and the OS allocates some space, heap, memory, and everything. And there some task is there there's some task is happening. Okay, just give me a moment, guys. So there is some task is happening, and suppose we have what we have it have a some set of CPU, it give to some set of memory it gives to him, and some set of you can say some extra resources what he need net call and all the thing that he needs, some kind of GPU he needs and all the some sort of it will allocate to this process. And inside it have a multiple threads. Suppose we have T1 to T90. These threads are some it is inside the process that is doing its job. Like chef, we have only in that restaurant we have stoves, so all the chef should use that stove only. So this is the process at thread basic example. So like I will give an example in this image as well. We have a RAM. In that RAM we allocate some space to process to happen, and inside that process we have the threads that is running behind the scene, which is utilizing CPU and all that to doing the task deliberately. Now take an example of Chrome tabs. You can say example, this is a Chrome tab, suppose, okay? And here if you see, when we create a tab, a capsule window will come. If you in these capsule windows, these are actually these are actually different processes is happening. They are not related to each other. But inside this window, if you open a site, if you open a site, if you open a site, then here all the threads are working for that site. Suppose you click on a fill the form, you click to upload files, you click to submit file, you click to process the video, and all that is happening for this process only. And behind the scene, when you do any kind of activity, threads will come into the action. Now threads have a in process, the option is like they are not dependent on each other, but in actually threads are dependent on each other. So suppose I will just giving a gist. I do not go deep and explain your deadlock and callback situation and await situation and all that. You should learn. uh it's you can just google it and learn it. So okay, we have T1, T2 and 3T. Now suppose T2 is a thread whose action is to do some like create file, and T3 is the task to process that file. So it dependent on T2 to do the task. If T2 is gone stuck in a state, if T2 is gone stuck on a state, so T3 never work. So what is the situation is called deadlock, or like starvation, you can say. Starvation is also situation come when the threads are waiting and CPU is giving memory and like enough memory, and uh, other process did not get the memory because he think he might come back and all that situation. So it's a kind of situation, it's he is waiting for to do the action and all the situation get logged, so it is called a deadlock situation. Okay, so here you can understand the concept of process and thread. I want to give an real example as well, so let's go a little more down. In the concept of process and thread, suppose you created a site. Okay, that site is, suppose you create our t-shirt brand that I will discussing still from starting of this lectures. Now initially your t-shirt size is fine, it's working fine, we have a 100 users, so it's fine, you allocate few memory for it and few resources for it, it's fine. Now what happens, suppose your sites just go up a lot, like 10k users suddenly came. So what will happen in that scenario? If it doesn't architect your process and thread arc thing not very well, and you are using like on 100 user we have 100 threads that doing the task, on 10k user we need 10k thread for doing the task, then it's very heavy task to do for your server. That's why we have a concept of synchronous task and asynchronous task. Okay, I will explain that later as well. Let I go to top. So you got the gist, right? What is process and thread? So process, you can say, a complete unit or some set of space that is allocated by CPU to do some task, and it have a some set of CPU, some set of memory, some set of CPU, memory, and GPU. Okay, and he is doing some task which is P0, and suppose P1 is another, so P0 and P1 is not mutually connected. Inside these we have threads which is running behind the scene and do the task when user clicks or anything happening between them, and it is using the resources inside these processes only. And it's very good because it is easily peasy, like data asynchronous is faster and all that. In processes also we can transfer the data and make it syncable, but there is also some processes also. Process to process recursion. Okay, now there is called context switching in CPU. You may know this thing earlier in your doing BTech. If you are currently in BTech, you may learn in this your OS segment of course, syllabus of the course. So what is context switching is like, suppose your computer is doing some task. If your computer is doing some task T, and in between of that task T0, it just go to another task T1, and then T1 done, then it's go to another T2, and then go to another T3. So this is the whole concept of context switching, in which in between of the process it change your threads or process is called context switching. Now context switching is very important in CPU segment because it's hallucinate user to do multiple tasks, because the actual CPU is actually do our task at our time until unless it's a multi-core CPU. So you should know like a multi-core CPU, dual core CPU, quad core CPU. So actually our core CPU only our task at time. If it have like a 8 cores, so it can do like 8 multiple process and multiple thing at the same time. It's not 8, it actually multiple, but you can say multiple thing at the same time. So this context switching help us to hallucinate the things. Okay, I am doing this task. It's little done. Okay, let's move to this task. Okay, it's done. It's the user is done with this thing. Okay, let's switch to that. But in the case of process, it's little laggy to just switch to another task because we have a lot of thing we have to move. But in thread, it's very easy. It's like just switch to this thing to this thing. Okay. So this is the concept of context switching in CPU. Now, see, this is multiprocessor. This is a multiprocessor. See. Okay, there is something happened. Okay, so if you know this is multiprocessing. This is multiprocessing. And if you see, this is a CPU and it have a worker, and it have CPU and a worker, CPU and worker. So if you see, there is a in the multiprocessing unit, we have a multiple memory space in which CPU is aligning task. And in the case of multi-threading, we have a one CPU memory allocated. In that we have a multiple thread are allocated were running the task. If you see this situation in this segment, when we are talking about processing, there are multiple CPU and memory blocks are allocated. But in the case of multi-thread, we have a shared space of one CPU and memory. So just understand one thing: in processing, we have a different blocks of CPU and memories, but in threading, we have only one block of uh, CPU and memory. Okay. So this is the concept of processing and threading. Let's move forward in how in actual life scenarios it affect, and how we when we design a distributed system on a distributed system and any kind of system, how it affect. Okay, so let's take an example of again distributed system. Sorry, our t-shirt store. So suppose, oh sorry, this is our site. Let's give a site. Let's give a site our name. So let's like our site. I will call from Tivantra.com. We launched eventra.com and think, oh, it's fine, it's fine, it's fine, and it's crazy good going on. And we set up the back servers to Apache. We set the server to Apache. So everything is going good now. And what we did, okay, sales are coming like, but sales are coming less. Like we thought, okay, the sales is coming like 20, 30, or like 100 users, and everything seems fine. And we are using Apache servers, and they are using like good we are using some good infra. I don't let do not conclude infra here, because then it's a big topic of discussion then. Okay, so it's like good 100 users are coming. It's an example I have to show you. So now, what happened to someone like someone bought our one T-shirt? Someone bought our one T-shirt. I'm bad at drawings. And that T-shirt he puts on Instagram. Okay, and it's viral, like crazy viral. Okay, now it's viral. Now what happened? At midnight, 11, suppose 11:59 to like 2 a.m. It viral, and most of the people window shopping during this time, and they visit our site. Now from 100 user to handle, suddenly our site have to handle 1 million user. Now what happened? If suppose just take an example with your laptop. Your laptop doesn't have enough CPU and memory, and you just putting Apache, like when you're putting some games like Forza Horizon, then GTA 5, then GTA 6, and continuously are opening a lot of what will happen? You just CPU crashed or it's not open. In the same thing happened. Your user see 503 bad gateway timeout. Okay, in that window where you receive a lot of business, but the user say 503 and you will get like suppose 200 your order, but you can maybe receive 10,000 of order. So what the loss you will get? What the loss you will get? A lot of loss. Suppose we have a t-shirt of 5 rupees. Let's take in for easy mathematics. You got a sale of 1,000 rupees, but you will get a sale of 50k rupees. So it's a total loss of 49.9k. 49.9k loss you got for this Apache server. Okay, I'm not saying Apache is bad, but we have a better alternative, or I want to explain Nginx. Nginx. Okay. So what is Nginx? So in spite of Apache, Apache doing one thing wrong here. Apache is doing one thing wrong here. Apache is doing, suppose any client or any user came to our site, he just create a new thread, a new thread. On each user came, on each user came, he create a new thread. Now for 1 million user, you create 1 million threads doing the activities. Even in the user scroll, user thing, there are non-blocking activities are happening, like asynchronous activities. Blocking activities happening, like they're clicking on login page and just trying to process the request and all that. Where the we need other user to just scroll the things. It stopped. 1 million thread is just waiting. Where in the case of Nginx, Nginx do things smartly. It is based on async operation. It is async event loop. So what we'll do, I will explain you very briefly. Just be conscious here. Suppose a request came here, a request came, request R1 and R2. Okay, R1 and R2 came. R1 ask, R1 ask, R1 ask, where is the file? Can you upload? So uploading, uploading a file is asynchronous activity. Means it's take, you don't know how much time it will take. It's just not sudden. So you can put in a loop, which is an event loop. You know the concept of event loop? In the JS, we learned that the event loop concept. You can just put in a queue that once it is done, give me back. Once it is done, give me back. Until unless, wait. And R2 should to move. So R2 not blocked due to R1. And it's not like fully loaded. Okay. We create a lot of threads. So it's a single threaded. It's a single threaded non-blocking server. That suppose you can say we have few workers W1, W2, W3, W4, and these worker doing the task asynchronously, putting the task in event loop. When it is done, give me back. When it is done, give me back. Until unless, let's move the other processes. Let do not wait for this to be complete, then we will move for other processes. Think in a server perspective. Think with a server perspective. You do not have like 1 million threads. We have few threads. Other threads are waiting. They are like other state. When they are done, then move that threads. So we can take a separate video on Nginx. It's just an example I want to explain you to Nginx and Apache. just an example to explain you how the server react basic behind on your process and thread model. So it is very important to understand process and threads. Okay, if the video is become a little large, but okay, so thanks for watching, and I think you will love this video. And if you want, I can create a separate video on and Nginx and Apache and how to set up the your whole thing, whole backend on Nginx as well. Nginx is an open source tool; you can use it. If you want that video, just comment it out. I love to read comments and then create videos on it. And thanks for watching. Keep subscribing, and stay tuned.